Hmm. So, what I'm looking at right now, let me just show you what I'm trying to debug. I put undo in off stream, but it doesn't totally work, and there's some very simple cases when it fails. So if I jump off this rock and I land, and then I do an undo, I go back to a time when there's no transactions, but there should be. Now I recorded this frame. So at startup, I call undo end frame, which is what, so we load the level. We theoretically do everything that we do after loading the level, and then we call undo end frame, and that pushes the initial undo state onto the list. And that's supposed to have all the transactions live that are going to be live. But it doesn't. Because when I look at the manager's transactions, there are none. So there, for example, the lily pads aren't moving. My character is not being supported, etc. Now, even if the lily pads aren't moving because we don't queue the lily transaction until the first frame, which we should do, honestly, we should just kick that off if there are any lily pads. And I will add that in a minute after this is fixed. Even if that's not set, the time till the next lily update should be right. So we have this thing. Here, let's we're going to make this undo record, and we set all these things in it, and one of them is time to next lily move, right? And then when we undo, we should get back that time to next lily move, and it should be, so it's 0 right now. And what that means, let's just go to the place, right? We're going to go into this lilies and rivers file later. And when we call update lily timer, it's not set to inactive because inactive is this negative number. So we're going to get there later, and we're going to say, okay, there's no transaction. Let's count the timer down. Oh, let's move the lilies. So this is why they start moving at the start of the level. Really, I shouldn't do this. They should really be moving initially. But given that this is the case, undo still isn't working right, because why then? Okay, first of all, if I just undo here without jumping off, then it works fine, which is weird. Okay, but if I jump off, and then undo, it doesn't? Are you kidding me? So that's really weird. Okay, wait, why don't I just look? Like, why does it work if I just do this? Right? So we have one undo record, which is what we expect. So this part here is, hey, as frames go on, we collect what's going to be the data for the next undo. And then the way we revert all that is we just commit all that and then roll it back. Not the same commit as the transaction commit, but like an undo commit. So we do that. And that's what this new, like if we made a new undo frame here, then we undo it. And that's the way of like reasonably rolling back all the state. So this is like the move that was happening. But then this is the initial move. And it's going to roll back this undo record, which has a time to next Lily move of 0. Right? Okay, so when we roll that back, it should work. So I wouldn't be that surprised, right? So it works. Okay. So now, what happens, like why is it different when I jump off and then undo? Okay, let's do it one more time, make sure that this is consistently broken. Yes. So whatever is broken is very simple. So I'm going to jump off and then undo. Okay. So same, we come down here. Now we've got an extra undo record because of our jump move, which is fine though. Okay, so the record that we're gonna get I might be guys. My undo system has been totally wrong this whole time. Ha ha. Here's what's going on. And I only realized this when I did the new thing. Ha ha. Lulz. I did it for the lulz, and they were the wrong lulz. Okay. So every node, so in these undo records here of which I speak, right? Each one of them is a node. Let me just go show what that is. It's got some stuff, but it's like, look, there's an array of undo records on the handler, and these are just every time you hit Z in the game, we pop the latest record and undo everything in there to move you back in time, right? And so what does that look like? It's this thing. What is that? Well, it's got an array of actions, and then it's got some other data that needs to be saved, like what was the time in the game? Because if any timers are ticking down, we need to restore the timer. How long is it till the next Lily move and rover update and all this stuff, right? Okay. And then what are the actions? Well, they could be a change or creation or destruction, and then ocean is its own thing for some reason. And then, it's just some data based on those, and then these are the different structs. So it's just some structs, right? No biggie. Except the thing is, if it's a change or a creation, this diff string is like we go and diff the members of the entity that are different from the default state and serialize that in order to keep it small. That's the only thing that's really tricky at all here. Okay, but the other point is this diff is kind of hidden here, but the diff is the old value and the new value both are packed for every member that changes in there. Just like here. So see, ocean change has old value, new value. Why is that? Well, it's because if you want to apply it backward in time, then you set the old value. And if you want to apply it forward in time, you set the new value, right? And that's what lets us use this undo system in the editor. It's what also, when we load your save game, we have all the undo in there and we just play all the events forward instead of backward and we restore the new value, right? But then we still have the old value so that if you hit Z after you load your save game, you can go backwards. Okay, so last night I added transaction data into here, and that's living on the undo record here. It's not serialized into your save game yet. It's just living here. So this is the same move transaction stuff that we've been working on for weeks in the rest of the game. Now, I realized when I first typed this in that I was using the wrong transactions because this is like a bridge of old data, new transactions, right? When you pop the latest undo state off the stack, right? Which transactions do you want to restore? It's not the ones from the record that you just popped, because those are the transactions that were live when the new values were live. But you're saying you're getting rid of the new values and going to the old values, right? And so what you actually want to do is go back to the previous node's transactions and use those, because that's what was current when you got to that state. It's a little bit confusing. It would in some sense be less confusing if, just like I have old value, new value, I had like old transactions, new transactions on every single one of these. It's just, that would be really redundant and annoying. So I believe all the information is there correctly to do it. It's just you got to get the transactions from the right place, which I think that I do. And so, I call this push transactions from record. And I say, okay, look, we should always have, after we do an undo, we should always have at least one left, because we don't allow you to pop the one from the starting game state, because then you would have no data. So if you undo back to the starting game state, we just leave that as the final undo. That's why we're asserting this is greater than 0. And then we say, hey, get the transactions from whatever the last record is after we popped our undo. All right. And this isn't what I was doing when I first put it in last night, but I was like, oh no, because I'm getting them from the wrong record. Okay. The problem is I'm getting time from the wrong record now, and I have been like the whole time that this code existed. So like when I go really do one undo, I think we were just looking at this code a second ago. I go here and I copy a bunch of stuff from the undo record to the entity manager, like what time is it, right? And what are all these timers and stuff. But this corresponds to the new data that we're actually just throwing away when we do this, unless it's a redo. Right? Okay. So what actually needs to happen, I think maybe I just move this stuff into push transactions from record. I think that's literally all I need to do. See, this function goes in both directions. It'll go undo or redo based on the value of this variable. Okay, so if I say push transactions from record, and I do all this, then at least no matter what, even if we call this on the right or wrong thing, at least now our transaction matches the timers. So what was happening there when I would undo and then nothing would be moving, it was because I had the transactions from move 0, which there aren't any because like I said, we don't initially kick off the lilies, we wait for the counter to time down. But I had the timers from move 1, which was after the lily transaction happened, and it set it to minus 100 to say, like, stop doing this, right? All right. Okay, so I reset. That's working. I jump off. I reset. Ha ha! Ha ha! See, we can fix bugs sometimes. Okay, so now I'm going to run around. I'm going to undo some things. Okay, that's a different bug. I don't know why. Like, for some reason, every time I undo to there, we make a new undo, so I can't go back in time to before that point, which is a drag. So let's just run around a little bit, and we'll undo all that. And this seems pretty consistent, right? So before last night, the transactions were not getting recorded. So if we did undos like this, the lily pad would be all messed up. It would be like flying off into nowhere. And now it's in the right place. So that's good. Do I have any tips for designing a nice, robust undo redo system? I mean, it sort of depends on what it's for, but my tip is understand clearly that the goal is to reproduce the data exactly, byte by byte, bit by bit. All right. If you don't do that, it's gonna not really work. And the problem is that the way a lot of people have learned to program, they don't even know what the bytes are. And so then they find something like that very hard. Whereas in fact, it's very easy. Well, it's not very easy, but it's reasonably easy, as long as you don't make goofy mistakes like the one that I just made. But then that mistake was not hard to fix, as you saw. I just moved some lines somewhere, right? So yeah, so we get to debug that next. So, you know, just be clear that that's the goal. You want to make sure you're very clear about what changes state and capture those changes precisely. That is not how I do it. Okay, this is worth mentioning. You might think that every time you ever change something in your game, you have to register that change in some way so that the undo system can make it happen. In principle, that's true. Like, you do have to record all the changes, right? But you could very quickly end up in like ugly object-oriented land where you have to call setters for everything, or where you have an error-prone situation where you know, you might change something without registering that you changed something, and then your gameplay code is broken all the time. I don't do things that way. I don't like it. I like to be able to just change what I want to change, and then the undo system will figure it out. And so that is how the system works in this game. Also in Braid, I do not record when I change an entity. I just change it. So my gameplay code is free to do whatever it wants. What happens is the undo system comes by later and detects the changes. And that's cheaper than it might otherwise be, because a large majority of entities in the world do not have changes as far as the undo system is concerned. And so they're factored out of that whole computation. So you only worry about the things that do. Am I using my float to hex? No, the undos are binary. You don't want to store stuff in text. That's crap. They're binary. So you have to understand what a floating point number looks like in binary, probably, right? You have to not be scared of that. I mean, you don't really have to understand it because you just have to know how big it is and whether it's the same as an old one, but it helps. It helps your feeling of security if you actually know what that looks like. In this case, how am I actually testing that I'm restoring the game state, or am I just verifying it visually? Right now, I'm just verifying it visually, right? In actuality, once this works well enough, we have hundreds of level tests that we will run through, right? And a lot of them will have to re-record, but they will all use or many of them will use lots of undo, and that's how we test the game. We can't do that yet because, like, for example, the fact that I can't rewind to earlier in time than this means that that's probably going to happen during gameplay a lot. So we have to fix that before we get to that point of testing the whole game. But it's really, we're not so far from that. 0.0f is easy to identify in binary files. What if it's minus 0.0f? We're not doing water rendering today. It says movement debugging. Not sure if you agree with that. You should ship the game with your game data in binary, but it's simply easier to look at it in text. You didn't listen to what I said. I said the undo data is in binary. The entities stored on disk during development are in text, yes. Because that's what works with source control, right? But when you're packing together diffed entity fields in undo data, you really want that to be fast, and you really want it to not take that much memory. And so text, I think, there is a mistake. That stuff doesn't have to go in source control. It doesn't ever have to be looked at by artists wondering what the hell is going on. It's like, you know. That, I think if you do that in text, you're just part of the problem with the whole HTML JSON generation. Yeah. Yeah, I could show, so for general entities, like here's our folder full of levels, and like this level that we're looking at is called Bardstone test. Where is it? Why do I not see? There it is. Because it was selected. So there's paint data here, which is a different thing, but we have the entity text files, and I can grab one of these and just look at it, and well, that's a group. That's not very interesting. Camera, the sun entity. Anyway, you like all of these. I'm trying to find a character. What ID is the character? 16.9.15. So 16.9.15. We can grab that. So that's the entity type guy. It's got some flags and stuff. We don't serialize out the flags to strings, but it's a number. And then all of these fields are, you know, all the various fields of the entity. The semicolon is a comment. So we put the name of the field here so that humans can read it. But when we load the data, we ignore these and just blast through. And another thing that allows us to blast through is that if this star is here, it means we have to load this field. If there's no star, it means that it's equal to the default value. So we just throw away the line. And this again, then, is only here for humans, really. But it says, it just reminds us what the default value is of these fields, but the computer doesn't need to load these. It doesn't need to parse these floating point numbers, for example. And when it comes to floating point numbers that we do want to parse, this float value colon hex value lets us say, ignore this, which is the slow part, just load this hex value, and you have the floating point number. So we actually load floats as integers. All right. You know, with Booleans, we just look at the first letter and so forth. So you can be pretty fast. Can I please suggest a laptop for software development? They're all terrible. I can't. I can't even buy one for myself, so no way am I going to be able to suggest one. How do you version this stuff? It's got the version number at the top, 17. You always wonder how I'm doing my game loop. Do you use a fixed time step with time-stamped inputs that are buffered from the OS? Or do you process the input from the OS as soon as they trigger? Do you use a fixed time step with time-stamped inputs? I mean, so basically we just have a loop that says read input, simulate based on that input, and then render, right? And we only read input once a frame. And we don't even look at timestamps on input right now to do like subframe whatever. Because the thing is, your input, I'm not really sure you want to look on at timestamps on input almost ever, even if they're available, which most operating systems don't give you. Because by the time you get input, it's always late anyway. Like it always already happened, and you always just want to respond to it as soon as possible. You don't want to wait before responding to input, right? I mean, unless you're already so low latency that you're somehow intentionally waiting in order to reduce variance of latency. But no, like the reasons games get slow, like 60 FPS is an okay frame rate, right? If you're able to render at 60 FPS and you don't do anything dumb, the game should at least feel good. It might not feel amazing like 240 hertz would, but it should at least feel good. The reasons why it wouldn't feel good if you're like triple buffering your output, or if you've got a multi-threaded renderer like Unity and Unreal have, where you know, the frame you're simulating is a frame or two late from the frame that you're rendering, that'll make your game feel crappy. Or if you just have your loop in the wrong order. So like if you render first and then read input, that's going to make your input be a frame later than it otherwise would be. So if you get all that stuff right, which isn't that hard, it's not that hard to make a game responsive. Also, you know, like if the player inputs a classic thing that games do badly when they're run by visual art people is that they delay inputs until animations are done or whatever, and that's going to make a game feel like crap every time. So you need to, like, if your character is doing an animation, you need to interrupt that animation to respond to the input. What does my OS layer do to inputs that fire before my read input call? We just don't see them until we get to read input. We don't have any kind of like asynchronous input thread or anything. I suppose that's possible. That is something that we could do. We just don't bother. I could imagine a version of the game that is a hair more responsive because we do that. But it's not really more responsive. See, the thing is, you can only really respond to events at the rate of your simulation step, right? All you can do by noticing events in between the simulation step is be a little bit more accurate. So like if I tap the key to start walking, I can't affect gameplay state involving walking until my next simulation step. But what I could do is say, oh, the distance that I walked is a little bit further. It's not just one frame, it's one frame plus a little bit because we saw this event come in. And so that's an accuracy thing. But you have to get pretty picky to notice that kind of accuracy, honestly. And so we don't generally do it. We probably should, but like, you know, we're a small company. We don't have a lot of people to do this kind of thing. Tell that to the developers of Street Fighter V. What, you mean, do they wait till animations are done before processing input? That's terrible. So a game like Bloodborne or Dark Souls, right? So part of the gameplay there is that you commit to a move and you can't break the move, right? Which is fine, but the character should still respond to the fact that you're trying to move it, right? That's the difference between games feeling good or not. So like if I committed to this big attack and then I try to move out of it, the game should say no, but like my character should like be jerking his head or whatever, or at least making a fail sound, right? As long as you do that, the player feels like their input is being responded to. You know what I'm saying? Or maybe like, you know, if the move is being buffered until that big move ends, that's fine too. But if it's a significant amount of time that you're buffering it, you still need to tell people right away that you buffered something. That's how you make a game feel good. Final question on this. So read input is checking all the key states on the keyboard and mouse, etc. in that frame when it is called. I don't remember what we do. We haven't sweated super hard about our input system yet. So we have this little abstraction. This is something like what you would have from SDL or whatever, where you have a common set of key codes that you could use on different operating systems and stuff, right? And we don't really try to define every key right now, but just the common ones that you might use. And so then there's an operating specific set of code that maps all the stuff to this, including events for key presses and whatnot, right? Okay. And then window stuff. And okay, so anyway, every frame we call a function that is defined per operating system. And I guess Ignacio changed this to raw input again or something. This is all new. I don't know. Anyway. Oh, I guess I did that. So that's for mouse stuff. We're using get async key state to make sure that like, so, you know, when you use window events, apparently you can lose window events and like the alt key can get stuck down or whatever. So we actually check this every time, which is stupid, to make sure they don't get stuck down. You know, we call our stupid ass Windows message loop that I wish wasn't a thing. I don't know why we're doing alt enter differently than how we did on the witness, but I've got that comment there about how that was. And then here's our Windows message loop. I mean, this all looks like what you would expect, right? It's just a bunch of garbage. And the point is, so when we get a key down event, we make our own event that's operating system independent. and it's just got the data we care about in a format that we care about, and then we just pass that off, right? And then the gameplay code, so read input says that, and then we call things that respond to the input, and their input response things just look for those events. It's just, the thing that sucks about all this is that the Windows message proc is really stupid, and it's not really how you want to do event handling. We did raw input for Windows in the witness, and I might bring that code over. Ignacio says we're using our raw input because there are no Windows events for some special keys such as print screen. So oh, wait, I guess he did put this in. So we are using it for Q. Then why do we have the window event? I guess we're doing both. Oh, okay. Well, okay. You need Windows events for like WM text or WM care, right? Because that's different from keyboard. But I am not sure. I am not sure why we have this, and I'm going to put that on the list. I need to understand now, because it looks like Ignacio put back raw input for keyboard, but then we're doing non-raw input for keyboard, and what's going on there? So that maybe we'll do that on a stream later in a day or two. Why is my Discord sub only? Because it's fun. It's fun to have an elite sub gaming lounge. And also, maybe it keeps the quality of discussion a little bit higher, although I'm not sure about that. In the game, you're using a movement system so that, for example, the character cannot jump until it has a foot on the ground. In the worst case, it means a delay that can be noticeable, but the movement is buffered and executed as long as it's possible. Do you think this would be a good experience for players? No. That is exactly the kind of thing that makes games feel terrible that you shouldn't do. You should not do that. The end. Can I comment on the reading in floats as integer hex? Okay, the definition of floating point numbers you can read. There's this thing called the IEEE 754 specification. You should read this. If I remember, the actual original document is pretty readable. How do I frickin' PDF? Screw you. Oh my God. Anyway, you can get the text of that document. And it'll tell you exactly what floating point numbers look like. Here's a Wikipedia page about it. This doesn't look as good as the actual document. Like, I don't understand how you can have these diagrams and not have the actual diagram of what the floating point number looks like. But anyway, you read this stuff and then you'll know what it looks like. And you'll realize that a floating point number is just an integer with some fields. Okay, here we go. Go to Kahan's webpage. This is probably good. Maybe not. No. No, this is not the right thing. Anyway, search this stuff. You'll see. You'll get it. And so you'll understand that a floating point number is just represented as an integer with fields that mean different things. There are 3 fields, okay? It's a floating point number is basically written like a number in scientific notation, right? Where you say a times 10 to the b. Remember how you learned that in science class? It's like that, except it's times 2 to the, or times 10 to the x, right? Where x means exponent. It's like that, but it's times 2 to the x, right? Because it's a computer. And so there's a field for like what's the base number. There's a field for what the exponent is. And then there's a field for the sign. So whether it's plus or minus, right? And that's it. So a floating point number is just those 3 things packed into an integer. And if you understand that, you're instantly a way better programmer than 99.9999% of programmers. It's like magic. It's like magic, dude. You can do things. Someone says you can get the PDF on Google Scholar. There you go. So read on Google Scholar the IEEE 754 specification. And then you'll understand what we're doing when we, whoops, let me find those files. So for people who are not super following along, so this thing here, when we save out our entities and we have these, right? Okay, well, you start to recognize things like, oh, 3F8, that's the exponent field. And these zeros, and then some of the bottom zeros from here are the mantissa field. And then the sign bit is 0. You could start to sort of read floating point numbers by looking at the integer a little bit. Not totally, right? You could sort of even tell by looking at this number, oh, it's less than 1. Right? It's not that much less than 1. It's a little bit less than 1. You can tell by looking at the integer. Anyway, things are a lot less mysterious once you know some of these things. Someone says, and once you understand IEEE, you can understand what floating point error actually refers to and why it happens. Yes, exactly. And then, so you will also understand which numbers are exactly representable in floating point and which aren't, right? Which numbers are the ones where if I set my variable to that and then print the variable, I could expect to see exactly the number that I wish I saw, and which ones do I see a different number, and why do I see that different number, right? You will understand all these things, and it's not even that hard. We're going to have some breakfast cereal so I don't starve. You know, our cafe cup from Ada's Technical Bookstore and Cafe in Seattle. Just don't program. Well, that'll work. Yeah, just don't program. Okay, let me do a small thing. I mentioned that when we start the game, wait, what does undo mark beginning do? Uh-oh, I'm going to add another no check-in. All right. It's just a little bit, maybe it shouldn't be, maybe not. Okay. So, level start reevaluate is what we want. So if there are any lilies, first we're going to update the flow direction. And then we're going to queue all the transactions. We're going to say, instead of waiting for some timer, we're going to actually move lilies. Actually, does that call update lily flow? It probably should, but it doesn't. Okay. So that should have no visual difference. It's just if I reset the game. Okay, well, I claimed it should have no visual difference. But actually what's happening is okay, this is actually a different bug that we need to fix anyway. So one of the no check-ins that we have is the following. Make sure all movement cases do this. Make sure they all set this target mobile supporter ID, and they're not doing that. And so what's happening is in the evaluate fall case. Okay, so the reason I'm falling now and didn't fall before is before the lily wasn't moving yet and didn't start moving until after this guy realized he was not falling or something, right? And then the lily would search for who it's going to move when it started moving, and it's like, okay. So now we've reversed the order of operations and revealed that the opposite order doesn't work, even though it actually should work, right? So what's happening is this lily's already moving. It's already posted its transaction. And then when our thing decides it's not falling because it's supported by that lily, it is not then saying, oh, let's set up a support transaction, right? And so then we fail. So we need to fix that. But first I have some more cereal. If you don't stop and eat your cereal, it'll get all soggy, and then nobody likes that. Are the distorted grid lines a shader effect? Yes. If so, how do they work? You just add a noise function to another function in threshold. No big deal. Okay, let's solve this. I actually have somewhere to go today, so we've only got maybe 30 more minutes in the stream. So let's fix this. And I think I'm going to look at evaluate fall for the rock. Let's get rid of this. These are both entity type rock. So we're going to delete this one. So if we see evaluate fall for a rock, we know it's the other rock. Here, hold on. Let's get rid of that breakpoint. Okay. So we'll start the game. We're going to let this happen. So now we're going to reset the level. Whoops. Okay. So we're slow down time. Come on, bro. All right. So I'm going to reset the level. Whoops. I took it out. Hold on. Leave the breakpoint in, reset the level. We didn't call evaluate fall. That's interesting. When does it happen? Maybe not till the first. This is weird. So what I don't understand, we are moving with the lily pad. And what that means is that the rock's support ID was set correctly by some piece of code, but I guess it wasn't evaluate fall. See, we're not getting to here until the lily pad crosses this line. Then that's when we actually fall. So who is setting the support ID? I guess update support. Let's just look at right. This is update support. That's the only thing that ever changes this, as far as I can tell. It should only be called from one place. Well, apparently it's called from two places. Oh, actually, well, the other one is here, right? So update support. All right. Okay. Oh yeah, we did this stuff. Okay, here's what we're going to do. If e.entity type is a rock, no checking, whatever. We're just giving ourselves a place to break. Okay, so this is good. We started the game. Let's make sure it's the right level. We're not like in an editor level or something. No, it's Bardstone test. Good. So we're calling level start reevaluate, which calls post undo reevaluate just as a subset of things. Because the things that you want to refigure out after an undo is a subset of the things that you want to figure out when you start a level. That calls update supports. And this is all, of course, happening after this thing that I just added, this move lilies. So that's what's different, right? So we're just a few lines down here and doing this other thing. So we're updating support. And so I guess when we do this, we want to add ourselves to whatever support transaction that is, right? See, this is a weird thing. I don't think this would be the right solution to complicate this. And now it is a little bit... I'm not sure how to handle this. Okay, so way one to handle this would be to say, hey, if we set the support on an entity, then go through and make sure we get attached to the support transactions. But that also is sort of already supposed to be handled by the transactions. They're supposed to call update support and check this stuff. The reason why this is causing this problem is because we just didn't do things in the right order. So what I'm tempted to do is actually change around when lilies start moving to be after this in the level start reevaluate, and assert when we call this that there are no live transactions. But the problem with that theory is that then we shouldn't really ever call update support anyway, because if you knew, if your transaction was in charge of doing the support move to make sure you don't fall off and drown like that, then why is this being tracked in a totally different way, and isn't that error prone? So I have like a structural thing to think about here. Okay. I'm really not sure what's the best solution. I kind of just want to think about it off stream for a while, because this is an important architectural decision. It's like doing this the right way could result in something that's clean and robust, and doing it the wrong way can result in something that's messy and painful. So I think I'm just going to defer this decision of what to do, especially because we've only got 20 minutes till I gotta leave. So maybe we just turn it into Q&A time, and then I just think about this, and we'll do maybe a different stream tonight where I do something about this. Like, I like to give my subconscious mind time to chew on stuff sometimes. So the deal is we're calling update support directly. So update supports even, so we're calling it at level start. We're also calling it in move transaction. And even that, even though this is the place that you want to call it from, okay? Why is that a separate thing from like if we're moving on to something, we should have the moving on to ID already. Right? And we don't 100% of the time because we don't set up our transactions super robustly, but we need to. So by the time I get here, if I'm committing a transaction, I should know on each of these moves what the new support ID should be anyway. Except in cases where there was a race. That's the trick. In case where there was a race and something moved into the support of where I was going to walk, I may not have known that in advance, right? So, but that's a rare thing. And I'm treating it here like it's 100% of the time that that's what happens. And I'm not sure that that's good because it just may lead to, like the way that this transaction system ends up being robust and solid and being part of a good feeling game is when it really like works. And if I hand wave around these things and it kind of doesn't totally really work, that's going to make everybody sad. So I need to think about this support issue. It's a little bit hard though because you can't see the future. So you don't know what's for sure going to happen. You know what you said was going to happen. So I'm going to walk onto this object. Yeah, my feeling is that we shouldn't do this. This was fine to get things working. My feeling is that it should come from the transactions, and if somebody moved into a square that would support somebody who's moving, then either we need to cancel the transaction, we need to fail it, or we need to handle it correctly. We need to transaction merge correctly, right? And that transaction merge would involve setting the correct new support ID on the guy who hasn't moved yet. Or if he has moved, he would end up in falling state because there was nothing there to support him. But then the thing would notice that he's in falling state and would then recover him from falling. I think that's kind of the good way to do it. But I want to think about it. I want to think about it. Yes, subconscious processing is very powerful. Most of you is not your conscious mind. So if you insist on solving problems only with your conscious mind, which isn't even possible, by the way, but if you insist on that, you're ignoring most of you. Are there any other moving platforms? There's lots of stuff. So there could be little rovers driving around that you could be walking on top of. There could be other characters walking around. There aren't that many things. There aren't that many different types of things that move automatically. But A, those that do move automatically, we want to handle completely robustly. And B, if you can like flail on the keyboard and make characters do the right thing really fast, that's just as bad of a problem. It's just harder to exercise. And normally if one character is moving, we block the other characters, except for stuff that we saw yesterday, like the wizard teleport in air. So if wizard teleport in air is able to cause problems, that's going to be annoying and stupid. So I think the right answer is that the way that support changes is when a transaction completes. And we had better know what the new support is at that time. Okay, although, to flip the coin for a second and say, what about if it's the other way, right? Really, the only reason that we want to store the support ID on the transaction is for cosmetic purposes. So actually what we could do it the other way, which is this actually is official. And if the cosmetics are off in weird cases, then they're off a little bit in weird cases. But we do this, and then here is where we officially add support transactions, and we don't do it in the cosmetic case. That might be a thing to do. See, and actually here, we almost do the whole thing, actually, now that I'm looking at this again, because we save the old supported by ID, right? We call update supports. Remember when I was talking about this the other day, how I wanted all this next to each other, right? It's next to each other. So we go over all the supports to update. If we already handled it, skip. If the support ID changed, we remove support moves. We don't add support moves here, though. Like if the old ID was 0 and the new ID is non-zero, we should add support moves. And we don't do that. We only remove. Although no, we do down here. So maybe this just isn't working. I mean, oh, right, okay. So the problem in this case, right, is that we called update supports from somewhere else. And like really, if we're going to be able to call that from somewhere else, all of this needs to be bundled in. Because if you ever change supports and you don't do all this stuff, then you didn't do this stuff, right? So maybe that's the problem. So we could fix that, and that would be legal. And I think either way of doing it will work, and I'm just not sure which one is the best. So I want to defer. I want to defer actually making that decision. The easiest solution is probably to put all this into update supports. I mean, I could do that right now, and then just decide late. I mean, let's just see what happens. Let's see how hard this is to do, because this will be useful information, for making the final decision about whether it should be this way. Right, so we're saying all of that and that line on top, right? So really this should probably be in the transaction. All right, so we've got to rename supports to update to entities. And then we need the, oops, I should have done this before I did that. So we're going to clear the flag first. We're going to do all this. That certainly makes this easier to read. Okay. Let's just see what that looks like. Oops. Well, that's fine. Recursively add support move. That is in file scope. Okay. Well, are we going to be sad? I don't know. Well, now the rock is going, but we're not. But we're also not falling. So what does recursively add support moves use as its criterion? Okay, first of all, we're using the same flag. This is not good. This is not good. So I'm using this flag to prevent things from recursing infinitely in weird cases where data is not correctly set up. So what are we doing here? So here, this flag is clearly only meant to be used here. So this is just to avoid doing double recursions or infinite recursions in cases where objects are interpenetrating for some reason. That's basically what's going on. Okay, this use of the flag then is completely not even happening. It's not even doing anything. Well, it may do, this one may do a little bit. I'm just going to make a separate flag. Because it's too complicated to think about. Like, I think I was originally trying to use the same flag in some smart way, but it's pretty clearly wrong right now, and it's too hard to think about, so it's like, forget it. They're orthogonal. However, so the problem here is that there's no guarantee that we're visiting these in the correct order. Right, so here, let's put all this stuff back in move transaction, actually. Because really, all right. I'm going to do this. We're going to have to fix that as well. So we have a sort in here. No, not sort transactions. Sorted supported. See, you have to process things in the right order. Because if you do like the top guy first, and you say, oh, if the middle guy is moving, make a transaction that I'm supported by his move. Maybe the middle guy wasn't moving, but then you do the middle guy, you know, and then you start him moving. So what I could do is factor this stuff out and reuse that to sort the dudes so that, see, because here, so before we go through this loop, everybody's supported by ID will be set. But what we're actually changing is this kind of stuff. I'm not sure why we're bothering to remove the entity also. That's an old thing. Like what? Why? Because we're not, it's not like we're iterating over this till it's empty. So like we don't need this. And even like in move transaction, ignores support by default. Which is not good. I don't think for this. Okay, so now we still don't do this in the right order. So we're going to do the following. All right. We're just going to keep this part. We don't want to keep the gathering of the things, but we're moving our sort function out to here so we can call it from multiple places. And what were we just editing? We were editing update supports, quick sort entities by sort supported. Canceled the game. Cancel the game. Who knows? I could have messed it up real bad. Oh, I messed it up real bad. What did I do? What did I do? Assert. Well, I'm adding a move. It's a support move going from 1761 to 1861. I don't know why sanity check gameplay position isn't. Oh, it's this one. Wait, the transaction is not closed? How's the transaction not closed? No, it is. See, okay, this is just Visual Studio, me not frickin' knowing what the hell is going on. Okay, where is this assertion happening? It's happening. Move transaction line 737. Okay. No, it is this one. Wait, this is wrong. This assert should be the other way around. This assert's been wrong for like days. It should be, if it's not, if we don't think it's, okay. Oh no, this transaction is right. Never mind. Never mind. When we add a support move, it should be okay if it's closed. So up here, okay, so the problem, like we're several, all right. So I could fix this problem relatively straightforwardly by passing OK if closed here. Frickin' Visual Studio, dude. Here. Wait, we do pass that. So it's getting dropped. Somewhere in this function chain, this value is getting dropped. But there's a different problem, which is recursively add support move is recursive, right? So it's going to walk up. It's going to walk up the entire chain of dudes, but update supports is also going to walk up the entire chain of dudes in this case, because it's going to go over. So we're processing some guys twice. And it's 10 o'clock. So it's time for me to go, but we will think about what is the best way to do this, and we will fix it one way or the other. People are saying no. Yeah, we have so many viewers right now. Early morning and afternoon is good viewer time for us. Yeah, so just to make clear what so even though I can fix this assert probably, I could just comment out that assert and it would be fine, because the only purpose of that assert is to catch things that don't seem to ever happen. So why are we bothering, right? But the problem is when we call update supports when we start a level, both of those things, so we've got like a lily pad and then a rock and then a character, right? And both the rock and character are not supported yet because we haven't computed support because we're initializing the level. So we figure out who they're supposed to be supported by. And now we're going through everybody, and we decided we called sort supported, so we're going from bottom to top, iterating up these guys. But then for the bottom guy, we're saying recursively add support moves, which then means that the top guy is going to be handled. Now, that might be fine as long as we have a flag we can look at to see if they were handled, which maybe we do if it's the other flag. I just need to think about it. But then we'd be checking both flags here, and that's like confusing. I think we would get rid of this one because I don't think this one's doing anything. I think we only use the other one. But that's a thing for me to think about. Leave, you mean like not be at the computer? Yeah, okay. I'm going to go not be at the computer for a while. So I add support moves twice? Probably. But I'm probably actually just flailing where I add the support move and then I remove it and then I add it again, and that's stupid, right? Like that can in some cases give you software that appears to work, but it becomes very Microsoft-like at some point. So we don't want to do that. Thanks everybody for coming by, and we'll probably stream again later today or tonight or something.